Hello viewers, in today's class we are going to discuss one important application of linear differential equation, right? And here we have to solve this problem. The problem goes like this, right? So here if F is a constant force generated by the motor of an automobile of mass m, its velocity v is given by this expression, right? M dv over dt is equal to F minus kv, where k is a constant, right? So we have to show that the velocity of the automobile after time t is given by this expression, that is v is equal to F over k times 1 minus e raised to minus kt over m when t is equal to 0 and v is equal to 0, right? So we'll solve this problem by the method of linear differential equation. So here we are given this expression, right? So m is the mass times dv over dt. dv over dt is the acceleration, and here we have F minus kv, right? And using this expression we have to find the expression for the velocity of the automobile after time t when we are given this condition, that is t is equal to 0 and v is equal to 0. So now let us start with this expression, right? Now let us divide both sides by m, right? So we'll have dv over dt is equal to F over m minus k over m, and here we have v, right? Now taking this term to the left hand side, so we'll get dv over dt plus k over m, and here we have v, and this is equal to F over m, right? So now this differential equation is a linear differential equation of order 1 and degree 1. So now if we recall the linear differential equation of this type, that is dy over dx plus py is equal to q, then we can easily see that for y we have v and for x we have t, right? So this differential equation is of this form, right? And we know that whenever we have a linear differential equation of this type, that is dy over dx plus py is equal to q, we always find the integrating factor of this differential equation, which is given by e raised to integral p dx, right? And the solution of this type of differential equation is given by y times integrating factor, and here we have integral, then we have q times integrating factor dx plus c, right, where c is the constant of integration, right? So in this problem we are given this expression m dv over dt is equal to F minus kv, right, where m is the mass, v is the velocity, F is the force, right, and F is the constant force, right, and k is some constant. So we have started from this expression and we have divided both sides by m, and we got this equation, and then taking this term to this side we have got this linear differential equation, and this linear differential equation is equivalent to this differential equation. So now if we compare this equation with this one, then y is replaced by v, which is the velocity, and x is replaced by t, because here we have x and here we have t, and p is k over m, right, and q is f over m, right? So now the integrating factor of this differential equation is given by e raised to integral p dx. So p is k over m, and for dx we can write dt, right? And see, k is a constant and m is the mass of the automobile, and this is also a constant, so we can now write e raised to k over m and integral dt, right? So this is e raised to k over m t, because the integral of dt is t. So the integrating factor is given by this expression, right? Now let us write the solution of this differential equation, right? So the solution is given by this expression. So y times integrating factor. So for y we have v. So here we have v times integrating factor is e raised to k over m t, and here we have integral q is f over m, and the integrating factor is e raised to k over m t, and for dx we have dt, and c is the constant of integration, which will be calculated by using this condition, that is t is equal to 0 and v is equal to 0. So now we have v times e raised to k over mt, and here f is a constant force, m is the mass which is also constant, so we can take f over m outside the integral, and here we have e raised to k over m t dt, and here we have c is the constant of integration, right? So now we can write v times e raised to k over mt, and here we have f over m, and the integral of e raised to k over m times t is e raised to k over m t, and we divide this expression by k over m, right? And c is the constant of integration. So here we have used this result, that is integral of e raised to, say, ax dx is equal to e raised to ax, and we divide e raised to ax by a, where a is some constant, right? So now this m and this m get cancelled, so we are left with v times e raised to k over mt, and this is f over k, because this m get cancelled, f over k e raised to k over mt plus c, right? So now we have obtained this expression, right? And now our aim is to find out this constant of integration. So we'll make use of this condition, that is when t is equal to 0, v is equal to 0, right? So when time is 0, here the velocity is equal to 0. So here when we substitute these values in this equation, here v is 0, so this entire term gets 0, and here f over k and e raised to 0, right? Because t is 0. So k over m times 0 is 0. And here we have c, and e raised to 0 is 1. So we have f over k plus c, right? So c can be written as minus f over k. So this is the value of the constant of integration. So now let us substitute this value of c in this equation, right? So we have v e raised to k over mt, and here we have f over k e raised to k over mt, and here we have minus f over k, right? For c we have minus f over k. Now v e raised to k over mt, and we can take f over k outside. So we have e raised to k over mt minus 1, right? Now if we divide both sides by e raised to k over mt, we'll get f over k, and here we have e raised to k over mt minus 1 over e raised to k over m t, right? Now we can write f over k, and if we separate the two terms here, then this term and this term get cancelled, so we are left with 1 minus 1 over e raised to k over m t, right? So now we can write v is equal to f over k, and we have 1 minus, and taking this term to the numerator, we have e raised to minus k over m times t, right? So this is the required expression, right? So viewers, this is how we can solve these type of problems by making use of the linear differential equation of this type, that is dy over dx plus py is equal to q.